Hello everybody, welcome into another lesson. So today we are going to discuss perfect square trinomials. And how do you obtain those? Well, you have a binomial raised to the second power. What you can do, the way we already know to do, is n plus 5 to the second power is the same as n plus 5 times the quantity of n plus 5. You just multiply it by itself twice there. And then we can use FOIL, n times n, that's n squared, plus we have n times 5, which would be 5n, plus 5 times n, which would be another 5n, plus 5 times 5, which would be 25. We simplify this, you'll get n squared plus 5n plus 5n, that's plus 10n, plus the 25. Okay, well that's one way we can do them, but are you really going to want to sit there and FOIL every time? Well, what if I told you there's a shortcut whenever you have a binomial to the second power? What you have to do is you take the first term to the second power, that n to the second power, plus you take 2 times the first term times the second term, plus you take the second term to the second power, which would be 25. And then what you would get when you do the multiplication, you would still have n squared plus 2 times n is 2n times 5, that'd be 10n, plus 25. So the answer you should get for this would be n squared plus 10n plus 25. So what you do is you're going to take your first term, raise that to the second power, plus you multiply the two terms, the n and the 5, take that times 2. It's always twice these two terms multiplied together, plus the second term to the second power. So that's how you do those. And I'll go over more examples here. Alright, we have z plus 8, that quantity raised to the second power. What you're going to do here, take your first term, that z, raise that to the second power, which would be z to the second power, plus 2 times the first term of z times the second term of 8, plus your second term to the second power, which would be 8 to the second, that's 64. So we go through and simplify this, you would get z squared plus 2 times z is 2z times 8, that's 16z, plus 64. So the answer you would get for this would be z squared plus 16z plus 64. I don't know about you, but to me that beats FOILing every time. Having to multiply it by itself twice and FOIL it. Alright, we have the quantity of a minus 9 to the second power. So what we do here, again, take your a, raise that to the second power, plus 2 times your first term, which is a, times your second term, which is negative 9, plus your second term of negative 9, you'll raise that to the second power. So we go ahead and we do the multiplication and the exponents. You'll still have a to the second power. Now you have plus 2 times a, which is 2a times negative 9. That'd actually be negative 18a. Plus negative 9 to the second power, that'd be positive 81. So the answer you should get for this would be a to the second minus 18a plus 81. we got p minus 10, that quantity, to the second power. What you have to do again, take your first term, raise that to the second power, that p to the second power, plus 2 times your first term, which would be p, times that negative 10, which would be your second term, plus you'll take that negative 10, raise that to the second power. So then you would simplify this, you'll get p squared, plus we got 2 times p, which is 2p times negative 10, that'd be minus 20p, plus negative 10 to the second power, that'd be 100. That'd be plus 100. So the answer you should get would be p squared minus 20p plus 100. And it's called a perfect square trinomial because you have both the first and second term have even roots, and then the middle term is literally twice the root of the first and second term multiplied together. So that's why it's called a perfect square trinomial. Alright, now it's going to get a little bit different. We have the quantity of 4n minus 1 to the second power. So suddenly the coefficient on the variable is something other than 1. Well, what you're going to do is still take your first term. You take that whole 4n, raise that to the second power, plus 2 times your first term of 4n times your second term of negative 1, plus that second term of negative 1 to the second power. Well, 4n to the second power, that'd be 16n squared, plus 2 times 4n, that'd be 8n, times negative 1, that'd be minus 8n, plus your negative 1 squared, that'd be plus 1. So the answer you should get for this would be 16n squared minus 8n plus 1. Alright, we got the quantity of 6c minus 1 raised to the second power. So what you're going to do, take your first term, that's 6c, you'll raise that to the second power, plus 2 times your first term of 6c times your negative 1, plus you'll take your negative 1 and raise that to the second power. Make sure you can see all that. Okay, good. Now the 6c squared, that'd be 6c to the second power, that'd be 36c to the second power, plus 2 times 6c, that'd be 12c times negative 1, that'd be negative 12c. So 36c squared minus 12c, plus that negative 1 to the second power, that'd be positive 1. So the answer you should get for this would be 36c to the second power minus 12c plus 1. Alright, we have 3y minus 8, that quantity to the second power. Well, what you're going to do is you're still going to take your first term of 3y, you'll raise that to the second power, plus 2 times your first term of 3y times your second term of negative 8, plus you'll take that negative 8, you'll raise that to the second power. So 3y to the second power, that'd be 9y to the second power. Plus 2 times 3y is 6y times negative 8 would be negative 48y. So you'd have 9y squared minus 48y plus that negative 8 to the second power, that'd be positive 64. So the answer you should get for this would be 9y squared minus 48y plus 64. Alright, now let's change it up again. We have 2r plus 9s to the second power. That quantity is to the second power. Well, you're going to still take your first term of 2r, raise that to the second power, plus 2 times your first term of 2r times your second term of 9s plus your second term of 9s, that term raised to the second power. So 2r to the second power, that'd be 4r to the second power. Plus we got 2 times 2r, which is 4r, times 9s, times 9s, that would be 4 times 9 is 36. R times s, well that's rs. Plus you would take that 9s to the second power, you would get 81s to the second power. So what you should get for this one would be 4r to the second power plus 36rs plus 81s to the second power. Alright, we got 5p minus 6q, that quantity raised to the second power. So what you're going to do still, take your first term of 5p, raise that to the second power, plus you'll take 2 times your first term, which is 5p, times your second term, which is negative 6q, plus you'll take your second term of negative 6q, you'll raise that to the second power. Alright, so 5p to the second power, that's going to be 25p to the second power. Plus we got 2 times 5p, which would be 10p. Well, 2 times 5 is 10 times negative 6, that's negative 60. So you have minus 60, p times q, that's pq. Plus we have negative 6q to the second power, that'd be positive 36q to the second power. So the answer you should get for this equation would be, for this expression rather, would be 25p to the second power minus 60pq plus 36q to the second power. Alright. Let's change it a little bit again. We have mn plus 2, that quantity raised to the second power. So now we have 2 variables on the first term. Well, you'll take your first term of mn, raise that to the second power, that would give you m squared n squared, plus you'll take 2 times your first term of mn, times your second term of positive 2, plus you'll take your 2 to the second power, which would be 4. So we simplify this, you would get mn squared, m squared n squared, plus 2 times mn, which would be 2mn times 2, which would be 4mn, then plus 4. So what you should get for this would be m squared n squared plus 4mn plus 4. Alright, let's change it again. We have 2ab plus c squared, that quantity squared. So we got the quantity of 2ab plus c squared, that quantity squared. Well, you're still going to take your first term, that 2ab, raise that to the second power, plus 2 times your first term of 2ab times the second term of c squared, plus you'll take your c squared, that second term, raise that to the second power. So your first term, the 2ab to the second power, that's going to be 4a squared b squared. Then you have plus, you got 2 times 2 is 4 times 1 is 4. That constant's 4. Then you have ab times c squared, which would give you a total of 4abc squared. Plus you have c squared to the second, which would give you c to the fourth. So the answer you should get for this would be 4a to the second b to the second plus 4abc to the second plus c to the fourth. Alright, here's a good one. Negative 6rs plus the quantity of s squared, that whole quantity raised to the second power. So what you're still going to do is take your first term, that negative 6rs, you'll raise that to the second power, plus 2 times your first term of that negative 6rs, times your second term of s to the second, plus you'll take your s to the second, raise that to the second, so now we go through and do the math here, deal with our exponents and multiplication. The negative 6rs, that quantity to the second, would be 36r to the second, s to the second. Plus, alright, let's deal with our constants. 2 times negative 6 times 1, that'd be negative 12, so you'd have minus 12 for the coefficient. R times s squared, well, we still have r, but s times s squared, that'd be s cubed. Plus we have s to the second, that to the second power, that'd be s to the fourth. So the answer you should get for this would be 36r to the second, s to the second, minus 12rs to the third, plus s to the fourth. I think we'll do a couple more here. Yeah, let's do a couple more. 2 more, then we're done for the night. So we got 9p to the third power plus 10. That quantity raised to the second power. So the quantity of 9p plus 9p to the third power plus 10, that quantity raised to the second power. Well, you're still going to take your first term, that 9p to the third, raise that to the second power, plus you'll take 2 times your first term of 9p to the third, times your second term of 10, plus your 10 to the second power, which would be 100. So let's do the exponents of multiplication here. Let's start with the 9 to the second. That would give you a coefficient of 81. Now p to the third to the second, that would be p to the sixth. Plus we have, let's start with our coefficients here. 2 times 9, that's 18, times 10, that's 180, times p to the third, which would give you p to the third. Then you have just plus 100. So the answer you should get for this would be 81p to the sixth plus 180p to the third plus 100. And I got one more example, then we are done for the night. Good one. Negative 11t to the second minus 2, that quantity raised to the second power. Alright, so we got the quantity of negative 11t squared minus 2, that quantity to the second power. So you'll take your first term, that negative 11t to the second power, raise that to the second power, plus you'll take your 2 times your first term of a negative 11t squared times your second term of negative 2, plus you'll take your negative 2 to the second power. Alright, let's do the exponents of multiplication. So start with a coefficient here on the first term. Negative 11 to the second, that'd be positive 121. Then t to the second, that'd be t to the fourth. So you have 121t to the fourth. Now let's do the coefficient on the second term. You have 2 times negative 11. That's negative 22 times another negative 2. That'd be positive 44. So you would get 44 then times t squared, which would give you the 44t squared. Plus your negative 2 to the second power, that'd be positive 4. So the answer you should get for this would be 121t to the fourth plus 44t to the second plus 4. So getting perfect square trinomials, whenever you have a binomial to the second power, you just take your first term, raise it to the second power, plus you take the 2 terms, multiply them, and then you multiply that by another 2. Then you add the second term to the second power, and that's really all there is to it. So next lesson we are going to factor perfect square trinomials. I hope everyone has a good night. Take care.